Today I am going to give you the knowledge of Nernst equation, and this equation will help you to calculate the concentration of the cell, equilibrium constant, and EMF, that is cell potential or electromotive force of the cell. See here, the relationship of electrode potential with concentration of solution, that is known as Nernst equation, means the relation which relates the potential of the cell with concentration of the solution is known as Nernst equation. Nernst equation gave a relationship between electrode potentials and the concentration of electrolyte solutions known as Nernst equation. For a general electrode reaction like this, means this is M stands for metal and N plus the charge of the metal, means it may be divalent, trivalent, monovalent and so on. And when this reduction of this cation will take, since the positive charge, number of positive charge is n, that's why it will take n electrons and it will come in the form of metal. The Nernst equation is, for this type of reaction, the Nernst equation for a single electrode will be like this. Single electrode. When a metal rod is dipped in a solution of the same metal ion, that is known as single electrode. So see here, this is the Nernst equation, and converting natural logarithm ln to log in the above equation, we get such type of relation where this stands for electrode potential E naught, that is a standard electrode potential with respect to a standard hydrogen electrode when concentration of M raised to the power n plus is 1 mole per liter and R is equal to the 8.314 joule Kelvin inverse or mole inverse, and mole inverse, Kelvin inverse, mole inverse, where M, concentration of M raised to the power n plus molar concentration of ions, and concentration of M stands for molar concentration of metal, and number of electrons gained, T temperature in Kelvin, and F Faraday constant, that is 96500 coulombs per mole. Hence Nernst equation at 25 degrees C becomes in the form of this, that is the electrode potential of the electrode is equal to the standard electrode potential of the electrode plus 2.303 multiplied 8.314 multiplied 298, because when you will convert the 25 degrees C into Kelvin, you will get 298 by n multiplied by 96500 log concentration of Mn plus by concentration of M is equal to this much plus 0.059 by n, because these all things 2.303 multiplied by 8.314 multiplied 298 by 96500. It these all things after calculation becomes 0.059, and n is the number of electrons used in this reaction. It may be noted that concentration of solid phase, that is concentration of M, is taken to be unity. Thus for simplicity, above equation can be written as E equal to E naught plus 0.059 by n log concentration of cation at 25 degrees C. Or you can write this in this way, or you can, for your understanding, for your concept, you can write this in this way also, means log the concentration of oxidized state by concentration of the reduced state. Now, calculation of cell potential of galvanic cells using Nernst equation. So before this, that was the Nernst equation for the single electrode. Now the Nernst equation for the galvanic cell, in which two electrodes are used, in which one is anode, another is cathode. So let us consider a galvanic cell of the type this much, in which the concentration of the solution may not be equal to 1 m. Now the EMF of this cell, that is cell potential, will be E cathode minus E anode, that is equal to the electrode potential of copper minus electrode potential of zinc, that is equation 1. Now using Nernst equation for copper electrode, we can write the Nernst equation for single copper electrode like this, as I discussed with you just now before this. Similarly for zinc electrode, this will become like this. For the single electrode zinc, the Nernst equation will be like this, and substituting these values in equation 1, cell potential will be E cathode this much, see, cell potential of the copper electrode minus this minus cell electrode potential of the zinc electrode. This is the electrode potential of the copper electrode, that is in right hand side, and minus the electrode potential of the zinc electrode, which is in the left hand side, according to the formula this one, E cathode minus E anode. Here the electrode potential of the copper minus electrode potential of the zinc. So when we for solving the cell potential of the cell, we will use this equation, and finally you will get the equation like this. And when you solve, you will get automatically this in this way. So when you will see in my notebook, you will become clear that how is it calculated. And now finally you will get the E cell, means electromotive force of the cell. Relation for the electromotive cell will be equal to the E naught cell plus 0.059 by 2 log concentration of copper ion solution by concentration of zinc ion solution. Now generally students become confused regarding this plus sign. This may be also minus sign when the concentration of the zinc ion will be above, means will be in numerator, and the concentration of copper ion will be in denominator, then this sign will become minus. So how will you remember it? I am suggesting you a technique or a strategy for this, you just remember, since anode, for anode we use plus sign, so the concentration of, for anode, sorry, for cathode we use plus sign, so the concentration of the cathodic ion will be in numerator and the concentration of the anodic ion will be in denominator. Remember, once again I am telling you, for in electrochemical cell, for anode we use minus sign and for cathode we use plus sign. So if you will put here plus, then you have to put the, after log you have to put the concentration of the cathodic compartment ion as numerator and the concentration of the anodic compartment ion as denominator. If you will use minus sign here, then the concentration of anodic compartment will be above and below that cathodic compartment. Now, in general, for a redox, so once again I am expressing this. See here, if you are not able to see, then see again here. The for your strategy, I am telling you, I am suggesting you that E cell is equal to E naught cell plus 0.059 by 2 log concentration of the cathodic compartment ion by concentration of the anodic compartment ion, because cathodic compartment, cathode is denoted as plus sign, anode is denoted by minus sign. So here is the plus, then in numerator you have to put the concentration of the cathode compartment, because cathode is denoted by plus sign. Hence, in general, this relation can be written like this. For a general reaction, small a, b, c, d are the number of moles of the reactants and products involving such type of reaction. The value of n, a, b, c, d can be obtained from the balanced cell reaction. From the text material will become clear here. There will be, you will feel no problem here. Just see the text material for this. Now, calculation of equilibrium constant from Nernst equation. The EMF of the cell may be used to calculate the equilibrium constant for the cell reaction. It is well known fact that the galvanic cell does not continue working indefinitely and stops working after some time. In fact, as the cell reaction progresses, the electrode potential of cathode decreases and that of anode increases. Ultimately, a stage reaches when electrode potentials of the electrodes become equal and the EMF of the cell is zero. Naturally, at equilibrium, the EMF of the cell will be zero. Means the electrons will not flow neither from anode to cathode nor from cathode to anode, which stops the flow of electrons. This state is known as equilibrium. Let us consider the following redox cell reaction like this. Let us assume that the cell reaction attains equilibrium and the concentrations of Zn2 plus aqueous and Cu2 plus aqueous are equilibrium concentration. Means concentration at this stage is known as equilibrium concentrations for both the electrodes. Means for both the compartment, means for both the ions of the anodic compartment, solution of the anodic compartment and solution of the cathodic compartment, they are known as equilibrium concentration at the stage of equilibrium. Then equilibrium constant Kc will be equal to this. See here, the Nernst equation for the above reaction, that is E cell is equal to E naught cell plus 0.059 by 2 log concentration of copper ion by concentration of zinc ion at equilibrium. Since E cell will become 0, that's why hence E naught cell will be equal to minus 0.059 by 2 log concentration of copper ion by concentration of zinc ion. Since here minus is removed, so the concentration of zinc ion will be in numerator and this will become in the form of denominator, because here minus changes into plus sign, that's why it has become like this. So this is the relation, and on the basis of this relation we can calculate the equilibrium constant, or equilibrium constant will be given, then the standard electrode potential, means standard cell potential will be calculated on the basis of this relation. Now the fourth relation is, so in general E naught cell will be equal to this significance of Kc. So the value of Kc is gives the extent of the cell reaction, means if the value of Kc is large, the cell reaction proceeds to larger extent, means if the value of Kc will be large, this means the amount of product will be large, this means the cell reaction will proceed to larger extent towards the product side, means forward direction. Concentration cell. Now here, a cell in which both the electrodes are of the same type but the solutions of electrolyte in which electrodes are dipped have different concentrations is called concentration cell. Means in both the for both the single electrodes same types of solutions are used, but their concentrations will be different. Means in the anodic compartment, if copper sulfate is present, then in the cathodic compartment will also the copper sulfate will be present. So here is this type of cell, the representation of a concentration cell you can see here. This is the representation of a concentration cell in which in anode the concentration, for the anode the concentration of the solution is C1, and for cathode the concentration of the solution is C2, where C2 must be greater than C1. Always the concentration of cathode, the concentration of the solution of the cathode should be greater than the concentration of the solution of the anode. In this case, the electrode which is placed in electrolyte of larger concentration acts as cathode, positive terminal, while the electrode which is placed in electrolyte of lower concentration acts as anode, that is negative terminal. Here the standard electrode potential of the two electrodes will cancel and the cell potential is given as this, because same types of electrodes are have been used in both sides, that's why this standard electrode potential will be same, that's why that term will cancel from the relation. Hence the EMF of the cell or the cell potential of the cell will be equal to 0.059 by 2 log concentration of the solution which is enlarged by concentration of the solution which is less, means the concentration of the solution of the cathode by concentration of the solution of anode. So here there is no need of the standard electrode potential. So while solving the problem in this type of, for the concentration cell, you will not require the data of the standard electrode potential, because here in relation it is not mentioned. So just you can see here, in general E cell will be equal to 0.059 by N, because this was copper, that's why it is 2 here, but in case of other type of, it will be in general N. So N may be 1, 2, 3 and so on, log C2 by C1, means the concentration of the right hand electrode by concentration of the left hand electrode solution, concentration of the right hand electrode solution by concentration of the left hand electrode solution. Evidently, for E cell to be positive, C2 will be greater than C1, then the E cell will be positive, because electromotive force should not be in negative for the cell reaction or for the feasibility of a cell. That's why, so I have taught you today 4 things. First, the Nernst equation for the single electrode, the calculation of the EMF of a cell, of a galvanic cell, and the third is the concentration cell, and fourth is the equilibrium constant from the concentration cell. See your notebook I am sending you, and then you will see my video. First you write the note from my text material that I am going to send you, and then you will read from the video, will try to understand from my video.